Molweni sanibonani shafere kunjani. I go by the name of Motizo. Welcome back to YouTube channel Amanyora. Please hit the subscribe button, the bell notification, and like this video. So today we're going to talk about the YouTube manometer. So YouTube manometer is an instrument that helps us to determine pressure in terms of pressure head. So it uses a transparent tube. So assume you have a cross-sectional area of a pipe and we are asked to determine how much pressure is in point A, which is this one. Or one more important disclaimer. The pressure in the same horizontal plane of the same liquid is the same. So the pressure in the same horizontal plane of the same liquid is the same. So pressure at this point is the same as the pressure at this point. So this ZZ, Z1 and Z2 is our data. So it is the one that we take our base on. So we are going to deal with three scenarios. The positive pressure inside the pipe, where we have more than two liquids in the U-tube, and then where you have a negative pressure or in the pipeline or the vacuum, right? So if we are asked to find how much pressure it is in the pipeline here at point 1, we know pressure in the same horizontal plane of the same fluid is the same. So the pressure at here, PZ1, would be equal to the pressure at PZ2, right? So now the pressure at PZ1 is equal to P1, which is the pressure in the pipe, yeah, plus the pressure due to this pressure head, H1. So it will be the density of fluid, this fluid, multiplied by the pressure head, multiplied by the gravitational acceleration, would be equal to the density of this second fluid on the right limb multiplied by H2, which is the pressure head, multiplied by the gravitational acceleration. So P1 would be equal to rho 2 H2 gravitational acceleration by minus density 1, pressure head 1 by gravitational acceleration. So this indicates the pressure inside the pipeline is positive. So you need to get a positive pressure in the pipeline. So when we move down, we'll look at when we have more than two fluids in the pipeline or in the transparent U-tube. So now, if you are asked to find the pressure at point 1 again, so remember the statement: the pressure in the same plane of the same fluid is equal to the same, or they are equal. So pressure at Z1 will be equal to pressure at Z2. So now to find P1 would be equal to pressure at this in the pipeline plus the density multiplied by the pressure head multiplied by the gravitational acceleration here of this fluid, this one, plus the density of the second fluid, which is this one, multiplied by the pressure head multiplied by the gravitational acceleration, would be equal to the density of the third fluid multiplied by the pressure head multiplied by the gravitational acceleration. So now we can find how much P1 is. And remember, this fluid is heavier than this fluid. So in the pipeline, you can either have oil, you can have milk, you can have water. Here you can have, other heavier liquids like mercury. So that's why you have more than one fluid in the U-tube manometer. Moving forward, where you have negative pressure in the pipeline, the same scenario still holds. Remember, the pressure in the same horizontal plane of the same liquid is the same. So pressure at Z1 is equal to pressure at Z2, right? So now to find how much pressure at this end is going to be equal to P1, which is the pressure in the pipeline, plus the density of this fluid, the pressure head H1, the gravitational acceleration rho GH, plus the density of the second fluid, the pressure head of the second fluid, and the gravitational acceleration is equal to 0 because there's nothing on top of, there's nothing here. So that means you have a negative pressure inside the pipeline. So now from here we're going to deal with one question which I've prepared for you guys. Let's move down a little bit. So now we are told that the manometer indicates a pressure head of 300 millimeters of water when measuring the pressure in the pipe, carrying oil with specific gravity of 0.7. For you to convert the specific gravity to density, we multiply by the density of water at 4 degrees Celsius, which is 1,000. I have earlier videos which talk about the specific gravity. So we are asked to calculate the absolute pressure. What is the absolute pressure? Absolute pressure is equal to atmospheric pressure plus the gauge pressure, right? So we are asked to calculate the absolute pressure in the pipeline if H1 is equal to 200 millimeters, right? So what are we calculating? We want to know the pressure in the pipeline. We are told that the manometer indicates a head of 300, which is 0.3 meters. So remember, the pressure in the same horizontal plane of the same liquid is the same. So now the pressure here would be equal to pressure at this point, right? So pressure at Z1 will be equal to pressure at Z2. So pressure at Z1 is equal to pressure in the pipeline plus the density of oil, which we're going to convert the specific gravity to density, multiplied by the gravitational acceleration, which is G 9.81, multiplied by the pressure head, which is H1. We are also told how much H1 is 0.2 meters. So it will be equal to the density of water multiplied by the gravitational acceleration multiplied by H2, which is H2 that we're given. So now is P1. We want to know how much the pressure inside the pipe is. So that's our unknown. So we converted the specific gravity multiplied by 1,000, which gives us 700 multiplied by gravitational acceleration multiplied by the pressure head is equal to the density of water, gravitational acceleration, and the pressure head of water. So we found out that P, the pressure in the pipeline, is 1,569.6 pascals, which is the gauge pressure. So remember, the questions wants us to calculate the absolute pressure. So we know absolute pressure is atmospheric pressure plus the gauge pressure. So the atmospheric pressure is 101,325 plus 1,569.6, and then the absolute pressure at that point or point inside the pipeline is 102.89 kilopascals. So that's absolute pressure. I go by the name of Motizo. Thanks for watching. Ola 7.